Hi, this is your host. This is a science show video. In the early 19th century, people in South Africa reportedly saw herds of massive elephant-like creatures lumbering around the veldt. They were called mala mola, which roughly translates to big things that go bump in the night. These mysterious animals seem to be about the size of an African bush elephant, but with much longer tusks. Unfortunately, no one was able to collect solid evidence of the mammal, not even a single bone. But it's left behind some tantalizing clues about what it was, where it lived, and how it went extinct. And we might have answers thanks to recent research into another extinct megafauna, woolly mammoths. The trouble with studying extinct animals is that by definition, they don't leave behind any living relatives. But occasionally, we can find animals alive today that are so bizarre they make us wonder if they could be the last of something much larger, like miniature marsupials, living fossils from a bygone era. To understand what these creatures tell us about their ancient relatives and what their continued existence means for conservation today, let's talk about one of the most famous examples, the okapi. When European explorers first heard reports of the okapi from the locals in the early 19th century, they assumed it was just a forest elephant. That is, until they saw one for themselves and realized it had zebra-like stripes on its hindquarters and a very long neck. The okapi lives deep in the forests of the Congo, which makes sense when you consider that it uses its long neck to strip leaves from high branches. They're also related to giraffes, as you can probably guess by the spots on their fur. The two split from a common ancestor about 11 million years ago, with giraffes evolving the extremely long neck we know today, while okapis kept their shorter, more flexible necks. At their closest, they share about 6% of their DNA with each other. That makes them about as closely related to each other as pandas are to deer. Because the okapi is our closest living relative, we can use it as a window into the past to learn about other extinct animals like the mala mola. It could help explain why there are so few okapi left in the wild today, only an estimated 10,000 or so, and it could shed light on the mysterious megafauna that once roamed southern Africa. But the okapi isn't the only animal we can use to peer into the past. Woolly mammoths still live on in modern day elephants. But the story goes back further than that. The ancestors of both elephants and mammoths were small proto-elephants, about the size of a warthog, that evolved into multiple species of megafauna in Africa and Eurasia. One of those species was the Gomphitherium. Its name means wedge tooth because of the shape of its teeth. It was about the size of a modern-day elephant and lived in Africa about 2 million years ago. In fact, scientists think there may have been a population of Gomphithers living as far south as South Africa at the same time that the mysterious mala mola roamed the land. One of those individuals would have been the ancestor of every woolly mammoth that would roam the Northern Hemisphere for the next 2.5 million years. As climate change caused grasslands to expand across the world, populations of Gomphithers migrated north from Africa. In Eurasia, they encountered a new ecological vacancy. That is, there weren't any large mammals to fill a particular niche. Enter the woolly mammoth. As the grasslands grew, the Gomphithers' northern relatives started growing bigger tusks and changing their diet to take advantage of all the new grasses. Eventually, after about 500,000 years, the ancestral woolly mammoth split from other elephants and became its own lineage. Mammoths went on to become the largest land mammal in most of the Northern Hemisphere and reached their greatest diversity during the last ice age. And yet somehow the Gomphither continued to survive in Africa for another 500,000 years. It wasn't until about 100,000 years ago that the Gomphither finally went extinct, only to be replaced by a descendant of that ancient African elephant, the straight-tusked elephant. We don't know exactly what caused the extinction of the Gomphither, but it's likely that a combination of environmental and geological factors played a role, such as the formation of the Sahara Desert and the splitting of the supercontinent of Gondwana. In Eurasia, the woolly mammoth thrived until about 10,000 years ago, right at the end of the last ice age. By then, the climate was warming and forests were replacing grasslands. Meanwhile, a new contender had entered the ring: humans. We hunted mammoths, but climate change was likely the main reason for their demise. So although the woolly mammoth and the gomphothere are two different lineages of elephants, they share enough similarities that studying them together gives us a clearer picture of how elephants evolved as a whole, and why the woolly mammoth went extinct. This approach has helped researchers study the mysterious Malamola too. Like the okapi, the Malamola is part of an extinct lineage of animals known as proboscideans, which includes both elephants and the extinct Gomphotherium. And like the woolly mammoth, Malamola lived at a time of dramatic environmental change. But unlike those previous examples, we have comparatively little to go on. Reports of the Malamola date back to the late 18th century, though many experts now believe the animal was already extinct by then. This is partly because it required large, open spaces to roam, which was the habitat that dried up first when the climate began changing about 30,000 years ago, so it likely died out before humans arrived in southern Africa. Still, it hung on for a bit. In fact, there's evidence that humans hunted Malamola to extinction, similar to the woolly mammoth, based on stone tools found near the skeletons of other large extinct mammals in South Africa. Researchers know that people were hunting megafauna there as recently as 12,000 years ago, so the Malamola might have gone extinct more recently than we thought. But it doesn't mean it died out recently. The Malamola was adapted for an environment very different from the one we live in today, which is why we've never seen one in the wild. For example, we know that Malamola lived in the dry southern tip of Africa, but we don't know how far inland it ranged. Recent research suggests that instead of hanging out on the coast, the Malamola preferred the dry interior of the subcontinent. Scientists used a computer program called Maxent to identify the most likely geographic range for the Malamola, based on its presumed preference for dry, open landscapes. Their conclusion: the Malamola probably lived farther inland than previously thought. This helps explain why we haven't found its bones in coastal areas. It's possible that future discoveries will prove that the Malamola did, in fact, live along the coast. But for now, the results suggest that humans hunted the Malamola to extinction in its native range. So the story of the Malamola shows us that humans do play a major role in extinctions. But when it comes to conservation, we need to focus on the main drivers of extinctions today: habitat loss and climate change. Both the okapi and elephants are threatened by those forces. Without intervention, both could face the same fate as the Gomphotherium, the woolly mammoth, and the Malamola. Understanding extinction isn't just about learning from the past. It's about ensuring we protect the biodiversity of our planet today. So thanks for watching this episode.